Hello, so continuing on January Leetcode Daily Challenge, one of the problems, today's problem is binary tree preorder traversal. So what this problem says is we get the root of a binary tree, and we want to return the preorder traversal of its node values. So preorder traversals means root first, then the left node, then the right node, right? So for example, here, first we do 1, the root node, then its left child, there is nothing, so we don't add anything. Then right child, which is 2, so we add 2. Then the left child of that, which is 3. And then right child, there is nothing, so we add nothing, right? So that's the idea of preorder traversal. So we can do this really simply using DFS. We can choose to do either DFS recursive or iterative using a stack. So let's do both, but first let's start with DFS. So recursive DFS. So what do we need? We pass in a node. And what do we need to calculate here? So we need to return the node first, but because we want it as a list, right? We want to concatenate it as a list. We put the value in a list, and then we add it to the whatever result we get from the left side. So remember, the preorder means, traversal means root, left, right, okay? And so the root here is this one, and then the left side, and then the right side. And the reason I said we are doing in a list here is so that we can concatenate list. If we just do this, it won't work because this returns a list for the left subtree, this returns a list for the right subtree, and so you can't add to a list to a value, and so we need to convert it to a list. Now what if we are at the last node? Let's say maybe we are at 3 and we go check the left side, which is nothing. Well, in that case we should just return an empty list because there is nothing. That way nothing will be added to the list, and so we can't just return nil again for the same reason, because we want to end up adding it as a list, and so you can't add the null to a list. You can say like 1, 2 plus null, right? And so instead we will return an empty list. That way it's just 1, 2, right? So this here will say if it's, so you can do either a node is none, or you could do just if not node in Python, and then we would return an empty list in that case. And now we have our recursive function. We need to start it by calling it on the root, and so we return that value. And this should work. Let's submit, and that passes. Okay, so that's the recursive solution. Now how do we change it to be an iterative one? So we need to use a stack instead. So we use a stack, and we initialize it with root in the same way we are starting here with root, and then we initialize the result that we want to return at the end. And now we keep going through the stack, and each time we extract the node, so we pop it, okay? And we, since it's root left right, which means we need to process the node first, which means basically we want to add it to the, we want to add its value to the result, but then we want to go through its left and right, okay? But because in a stack, if you add 2 first and you add 1 later, 1 would be popped first, right? So if we do the same order and add left first and add right on top, then right would be processed first. But that's not what we want. We want left processed first. And so we add left the last one and then right first. That way when we extract, the first one we extract is left. And so here, when we are going through the child, we want to start with right and then do left. So let's just do it. So append node.left right first, then add node.left, so that when we pop the left side first, so that we expect this order, right? And now there is only one thing, is what if the node we added was null? In that case, what we want to do is we want to check here if node, then we do all of this, okay? And that should be it. So let's run it, and looks good. Let's submit, and that passes test cases as well. Yeah, so that's pretty much it for this problem. Please like and subscribe, and see you on the next one.